division. Our first section is division with remainders. You might remember remainders from that practice problem that I did last chapter during a problem-solving section which asked about somebody's age. But we're going to go into more depth for remainders. Interpret the remainder. There are 75 people seated at tables. Each table seats 6 people. How many full tables are there? How many people are sitting at a table that is not full? How many tables are needed for all 75 people? So the quotient would be the number, yes guys, the hashtag sign is also the number sign, of full tables. The remainder would be the number of people at a not full table. And when we add 1 to the quotient, it would be the total number of tables. What would that be in this situation? 75 divided by 6 is equal to 12 remainders 3. So the quotient is 12. The remainder is 3. And if we add 1 to the quotient, then it'd be 13. So there's 12 full tables, 3 people at a not full table, and 13 tables in all. Now we're going to do a practice problem. There are 100 people who volunteer to clean the park. They will form into groups of 8. How many groups of 8 can they make? Which of the following statements is true? They will make 15 groups. There are 8 people in a group. There are 98 volunteers. So there are 8 people in the group is already given in the problem. And 98 volunteers is directly disproved by the problem. What about 15 groups? Well, you end up with 12 remainder 4, which is 13 groups. 13 is not equal to 15. Therefore, B is the only correct statement. Now, we're going to do some division. 81 divided by 7. From our knowledge of multiplication tables, we should know that 81 divided by 7 is not a whole number. So we do 81 divided by 7. 8 divided by 7 is 1. And that leaves us with 11. And then 11 divided by 7 is also 1. And that leaves us with 4. 11 remainder 4 is our answer. How do we check? Well, 7 times 11 is 77, plus 4 is 81. Now, 62 divided by 6. 62 divided by 6, and we get 1 and 2. 10 remainder 2. Check. 6 times 10, 60, plus 2, 62. Now 34 divided by 3. You get 11 remainder 1. 11 times 3 is 33, plus 1, 34. 78 divided by 4. 7 divided by 4, 1, and then that's 3, 38. 38 divided by 4, 9. And that's 19 remainder 2. 19 times 4 is 76. 76 plus 2 is 78. 7 divided by 3. Wow, 2 times 3 equals to 6. 2 remainder 1. 6 plus 1 equals to 7. 54 divided by 8. So what's the closest that we get? That's smaller than 54. Well, there's 48. So 6 remainder 6. 6 times 8, 48. 48 plus 6, 54. Now we move on to the next section. Of course, if you want to take a break, feel free to do so. Section 2, divide multiples of 10, 100, and 1000. You can use patterns or basic facts to help you divide multiples of 10, 100, and 1000. So we can use multiplication patterns or we could use basic facts, at least for now. So 8 times what equals to 24,000? 8 times 3 equals to 24. So 8 times 3,000, which has 3 zeros that we need, is equal to 24,000. Therefore, 24,000 divided by 8 equals to 3,000. What about basic facts? The basic fact for 24,000 divided by 8 is 24 divided by 8, which is equal to 3. And then you add the 3 zeros, which is still 3,000. Now let's do some practice problems. Actually, no. And yes, because we're completing patterns here. 63 divided by 7, according to our good old handy multiplication table, is 9. Now what's 630 or 630 divided by 7? Well, it's 9 plus a 0. What about 6,300 or 6,300 or 6,300 divided by 7? Well, it's 9 with the 2 zeros. 28 divided by 4, 7. 280, 280 divided by 4, 7 with a 0. 2,800 divided by 4, 7 with 2 zeros. 42 divided by 6, 7. 420 divided by 6, 7 with a 0. 4,200 divided by 6, 7 with 2 zeros. 50 divided by 5 is 10. 500 divided by 5 is 10 with another 0, 100. 5,000 divided by 5 is 10 with another 2 zeros, 1,000. Now we move on to divide using patterns. 1,000 divided by 2. 10 divided by 2 is 5. And then we have 2 zeros left over. Because, well, 10 and then 2 zeros. 400 divided by 8. 40 divided by 8 is 5. And then we have a 0 left. 50. 180 divided by 3. 18 divided by 3 is 6. 1 0 left. 60. 720 divided by 9. 72 divided by 9. 8. And then 1 0. 3,600 divided by 4. 36 divided by 4 is 9. And then there's 2 zeros. 900. Section 2 done. Now we move on to section 3. Problem solving. Remember guys, if you want to take a break at any time in the video, feel free to do so. Use the guess and check strategy. Okay, remember what I said last chapter. Don't guess it. Try not to guess and check unless you have to. And if you're doing guess and check, try to do it within a logical range, because guess what? There's an infinite number of numbers out there. You're not going to do all of them. You're not going to be able to do all of them either. Etta fills a bottle with 10 inches of colored sand. She has 6 inches more of green sand than of blue sand. How many inches of each color does she use? What do we need to know? We know that there's 10 inches of colored sand and 6 inches more green than blue. And what do we need to find? How many inches of each color? So our plan would be guess and check, but I'm not too fond of it. Therefore, it's going to be math. I'm going to show you how to do it with guess and check though. So guess and check would be if there was 1 inch of blue sand, then there would be 7 inches of green sand. 1 plus 7 equals to 8, which does not equal to 10. If there was 2 inches of blue sand, then there would be 8 inches of green sand. 2 plus 8 equals to 10. So that's our answer, but here's how we do it with algebra. G plus B, green plus blue, equals to 10. Green equals to blue plus 6, because there's 6 inches more. And then you substitute this in, and you end up with B plus 6 plus B equals to 10, and then two B plus 6 equals to 10. And remember about that stuff about solving addition equations? You subtract. So 2B equals to 10 minus 6, which is 4. B equals to 2. Yeah, this would be the algebraic way. Is the solution reasonable? Yes. Reread the problem. Etta fills a bottle with 10 inches of colored sand. She has 6 inches more of green sand than of blue sand. How many inches of each color does she use? Does your answer make all of the statements true? Yes, it does. Oh yeah, and by the way, green equals to 8. Usually a very good way to solve or, well, check a problem is to solve it 2 different ways, which we just did. We kind of did a little bit of guess and check back there without writing down anything, so. Anyhow, moving swiftly on to the practice. A group of friends share 40 gummies equally, with 7 gummies left over. There are more than 6 friends. How many friends are there? How many gummies does each friend get? So, if there's 7 gummies left over, then it's 40 minus 7, which is 33. And 33 has the factors 1, 33, 3, 11. So if there's more than 6 friends, then there's either 11 friends or 33 friends. Either 11 or 33 friends, each getting 3 or 1 gummies, respectively. Anyhow, Lillian invites 6 friends to her party. She wants each friend, not including herself, to have 4 balloons. She has 28 balloons. How many balloons will she have left over? So not including herself, it would be 6 times 4, which is 24, and 28 minus 24 is equal to 4. So she will have 4 balloons left over. Have 4 balloons left over. Now, you could probably realize by this point that if we just went in blind, just guessing and checking, that we would probably have taken a lot more time to get our answers. Now, moving on to the next section, which is estimating quotients. I mean, hey, at least they taught you basic division before, and they did talk about dividing decimals before, so dividing whole numbers isn't all that difficult in comparison. Compatible numbers are numbers you can divide easily. You can use compatible numbers to estimate quotients. Compatible numbers really are just those pairs of numbers that you see on your multiplication table, if you think about it. Now, estimate 6,253 divided by 9. Now, if you think about it, what's something close to that with 9? Well, 7 times 9 is 63. So that would be something like 6,300 or 6,300 divided by 9, which is 700. Therefore, this is also around 700. Now we're just going to do some exercises. No, not physical exercises, mental exercises. Estimate 2,035 divided by 4. Now we already have 20 over here. 20 divided by 4 is 5. So the division fact would be 2,000 divided by 4, or 20 divided by 4, which is 5. So the estimate would be 500. Now what about 6,658 divided by 8? Well, 8 times 8 is equal to 64. So that would round to, well, I mean not round, estimate to 800. Now we continue with 3,607 divided by 7. So what's a division fact or multiplication fact with 7 and something close to 36? 5 times 7 equals to 35. So 35 divided by 7 is equal to 5. And that would be 5 over here and 2 more zeros. So the estimate would be 500. Oh, 500 again. Huh. Interesting. You should probably make your 5s look less like S's. Estimate 9,538 divided by 9. Well, 9,000 divided by 9 is 9 divided by 9 is equal to 1, so the estimate would be around 1,000. It would be more close actually to 1,100 because, well, 5 is more than halfway to 9. But anyways, it's also close enough. Now we're going to do some more estimation while checking our estimate. So 1,056 divided by 9. Okay, so I mean 10 is close to 9, so this would be approximately 100. Even though it's honestly closer to 111. Actually, no. It's closer to 116. The actual answer is 116 remainder 2. Then we have 4,124 divided by 4. I don't know why you would want to estimate for this because this actually divides out into a whole number. For your information, that whole number is 1,031. So anyhow, 4 divided by 4 is 1. So an estimate for this would be 1,000. Here we have 5,684. Is that actually divisible by? Nope. So what is something that is close? 6,000 would be close enough. So that would be approximately 2,000 as the estimate. Here we have 6,300 and 19, you could use either 6,500 or 6,500, or you could use 5,000. 5,000 would be more far off, so we're just gonna use 6,500. And that would be 65 divided by 5 is 13. Approximately 1,300 would be a good estimate. Now here, it's 3,695 or 3,695 divided by 8. 32 is a good, well, it's not exactly good, but it's close enough. So 32 divided by 8 is 4, so that'd be around 400. 400, but honestly, 3,695 is closer to 4,000 than to 3,200, so 500 would be a closer estimate. Anyhow, moving on, we go to 1,946 divided by 7. 2,100 or 2,100 is close enough. 21 divided by 7 is 3, and then there's 2 zeros, so a good estimate would be 300. Yeah, I'm not really fond of estimation when it comes to division, but anyhow, now we're going to move on to two-digit quotients. Here we have 27 divided by 4. So we could draw the long division box, thingy, whatever you want to call it. And the second number goes on the outside of the box. The first number goes on the inside of the box. I know some people really don't like remembering the terms of these. And honestly, you're not going to be using the separate terms for the first number and the second number at all in the future. Although it's good for trivia, though. Anyhow, 427. Okay, can't really do much for this one. 4 times 6 is 24, so minus, and then it's remainder 3. There. It's really not that difficult from other long division, and since we've already learned long division in dividing decimals, well, I mean, hey, dividing decimals was not more difficult than this. In fact, most people learn dividing decimals after whole numbers. Anyhow, 82 divided by 7 equals to, so then the 7 divides into 8, you subtract. At one point in life, I just stopped using these subtraction signs because it's going to be subtraction anyways. It's always subtraction when you're doing long division. There's no addition. So there's really no point in writing this subtraction sign once you get used to the fact that it is subtraction. I don't know why some people still write it, but anyhow, you subtract, then you drag the next digit down, you get 12, 7 goes into 12 once, and you subtract again, and you get the remainder of 5, so the answer is 11 remainder 5. 92 divided by 6, 9, 2, 6. 6 divides into 9 once, and then you subtract, get 3, 32, 32. 6 divides into 32 5 times, you get 30. 32 minus 30 is 2, that's the remainder, so it's 15 remainder 2. 39 divided by 2, well, 2 divides into 3 once, so you subtract, you get 19. 2 divides into 19 9 times, you subtract. 19 minus 18 is 1, so you get 19 remainder 1. 67 divided by 9, well, you can't really divide 9 into 6, and it's 67 anyways, so 7 times 9 is 63. And then it's 63. 67 minus 63 is 4. 7 remainder 4. Woohoo! We're done that. Now we're moving on to problem solving. If you want to take a break at any point in between sections or just any point in general, feel free to go ahead. If you just came back or if you stayed, well, hi! We're going to be discussing the pros and cons of various strategies. A 4-step plan. Well, the 4-step plan is a standard plan for all of them. Step 1, understand. Step 2, plan. Step 3, solve. Step 4, check. Here's how we go about doing it. Alice wants to buy jeans that cost $34, a shirt that costs $26, and a belt that costs $25. That is an expensive belt. She has $80. Does she have enough money? Step 1, understand. $34, $26, and $25 is what she wants to spend. She has $80. What do we need to find? Does she have enough money? Plan, we could use simple addition and subtraction. Well, actually, no, not even subtraction. Addition and comparisons to figure it out. Step 3, solve. We actually do the addition. 34 plus 26 plus 25 is equal to 85. So 85 is bigger than 80. Our conclusion is no, she does not have enough money. Step 4, check. You look, is it reasonable? Did you do everything correctly? Are your facts correct? 34, 34, 26, 26, 25, 25. 4 plus 6 is 10. 10 plus 5 is 15. You have a 5 over here. You regrouped a 1. 3 plus 2 plus 2 plus 1 is indeed equal to 8. So we do have $85. Well, we don't actually have $85 because she only has $80. But our answer is correct because 85 is indeed bigger than 80. This is the standard that everybody uses. Now you may think, oh, I don't use this. Yeah, you technically always do. You might not consciously think, oh, step 1, do this, step 2, do this, but if you're reading a question, you're automatically going like, what do I need? Am I missing anything? What do I need to find? Okay, that's my goal. Oh, how do I do this? How do I do this problem? Okay, do this. Let me do this problem. And then you do the problem. And then you go back and you look, did I do everything right? That's the general gist of this strategy. Now we move on to the next one. Work backward. Some questions you have to work backwards for. That's the only way to solve that question. If they give you information right now and ask you for something in the past, then you usually have to work backwards. For example, Alice bought the jeans for $34 and a shirt on sale for $15. She has $65 left. How much money did she start with? So you're asking for something in the past. That's when you have to work backwards. In the past. A strong sense of déjà vu. Anyhow, déjà vu is French. It means already seen. Alice bought the jeans, blah, blah, blah. So how would you go about doing this? She spent these two values, which means that if she has this value left, then the original would be the values all added together. And that would be $114. She started with $114. Now there's also make a table. Make a table is for organization, organizing information. It's very helpful when you get confused. But sometimes, in younger grades, making tables is also used to find patterns, usually. In older grades, well, you just go with straight up algebra, i.e. a pattern. Alice bought jeans for $30 and a belt for $7. Carol bought jeans for $17 and 4 belts for $4 each. Who spent more money? So Alice, A, has, that's an A, guys, 30 and 7. Carol has 17, 4, 4, 4, 4. We add them up, 37, and then this would be 33. And last time I checked, 37 was bigger than 33, so Alice spent more money. Because this question doesn't actually have a truckload of information, you don't really need that much of a table. Moving on, a pattern. So a pattern is, oh no, suitable for algebra. There's a reason why it's called patterning in algebra. So what's the next number in the pattern of 2, 6, 18, 54, something? So 2 to 6 can either be you add 4 or you multiply by 3. Now 6 to 18 is definitely not add 4, but it is multiplied by 3. And 18 to 54 is also multiplied by 3. Now what's 54 multiplied by 3? Come on guys, you learned this last chapter. 162 is the next number in that pattern. There's also guess and check. The thing that you use when you have absolutely no idea what you're doing. Or you don't really know what you're doing, but you're trying to still get something that has a vague resemblance of the answer. Anyhow, solve for Q. 13Q plus 1 equals to 27. If Q equals to 1, then if Q equals to 1, 13 times 1 plus 1 equals to 13 plus 1 equals to 14. If Q equals to 2, 13 times 2 plus 1 equals to 26 plus 1 equals to 27. Q equals to 2. This is how guessing and checking works. Because of the fact that it takes a long time and you might not get to the answer for hours, it is usually not the first thing that you go to. If you have any other inkling, clue, inkling and clue, they're similar enough. They're synonymous enough to be used like that. If you have any inkling what you're doing and what you want to do and how to solve the problem, try not to use this unless your inkling to solve the problem is to use this. Which, I mean, there's a few types of problems, but try to go for a logical guess instead of just plain guess and check. Now the last one, acting it out, the one that I absolutely hate. Because why? You're not going to be able to do it on a test. And, well, math classes have a lot of tests. And university and college has, well, exams too. Andy has 5 bills that total $60. What bills does he have? So we know the customary bills. It's obviously not, actually, yeah, it's not. You obviously can't have a $50 bill because you can't have 4 bills with a total of $10. You could have bills and coins that have a total of $10, but not bills, not with only bills. So the next option would be to have $20 bills. They can't have 3 $20 bills because 3 $20 bills is already $60. So let's just say they have 2 $20 bills. So 2 20s, and that's $40. So there's $20 left, and we need 3 bills. I mean, you can't have 3 $10 bills because that'd be 30, but you could have 1 $10 bills and 2 $5 bills, which is 20. Well, now we know what bills he has. 2 $20 bills, 1 $10 bill, and 2 $5 bills. We are going to move on to solving division expressions, equations with 3-digit quotients. If you want to take a break at any time during this video, feel free to do so. Here we have 824 divided by 4. So 824 divided by 4 would be like this. 4 divides into 8 twice, and that leaves us with 0, 2, but 2 can't really do anything, so we're just going to put a 0 up here to get the 4 down. And 4 goes into 24 6 times. So the answer is 206. We're going to do a few more practice problems to solidify our knowledge. And 152 divided by 8. Here's a question you have to ask yourself when you're dividing with, well, numbers that have more than 2 digits. 8 does not go into 1. So you move 1 digit, well, you include 1 more digit. And 8 goes into 15 once. And then it's 7. And then you drag down the 2. And 8 goes into 72 9 times. The answer is 19. 2, 185 divided by 5. 5 does not go into 1. 5 does go into 18 3 times, and you get 15. 18 minus 15 is 3. You drag down the next digit, 35. 5 goes into 35 7 times. And you get that the answer is 37. Here we have 269 divided by 4. This is going to have a remainder. So 4 does not go into 2, but 4 does go into 26. If you do 6 times, then it will be 24. And 26 minus 24 is 2. You drag down the 9, 7, and then you get 28, and then you get remainder 1. The answer to 269 divided by 4 is 67, remainder 1. For our last question of the section, we have 734 divided by 7. 7 goes into 7 once. So then we drag down the 3. But the 3 isn't enough. We need to drag down another digit. So we added 0 over here. And by over here, I mean on top of the 3. 7 goes into 34 4 times. And you get remainder 6. The answer is 104, remainder 6. Yay! So we move on to quotients with zeros. I mean, we've already done 2 of them, but we're going to continue talking about them. Now, quotients with zeros really aren't that different from normal quotients. Now, find 812 divided by 4. So then 4 goes into 8 2 times. You do a subtraction, you drag down the 1, but then you realize it isn't enough. So in order to drag down another digit, you need to add a 0 to the quotient. You drag down the other digit, 4 goes into 12 3 times, and you're done. You get 203. It's not all that different from normal, well, not exactly normal, but this is normal. Quotients without zeros. Now, let's do some division. Oh, okay. 883 divided by 8. 8 goes into 8 once. You drag down the next digit. 8 goes into 8 once. You drag down the next digit. But, well, you can't do anything with this digit. So you add a 0 on top of that digit and put a remainder. Because in case you haven't noticed, 8 times 110 is equal to 880. 8 times 11 is not equal to 880. It's equal to 88. Solution 110, remainder 3. Here, we have something else. 632 divided by 6. Six goes into 6 once. You subtract, drag down the next digit, but the next digit isn't enough. So to drag down the other digit, well, the next digit, you have to add a 0. And you get 32. 6 goes into 32 5 times with a remainder of 2. You get 105, remainder 2. Oh, okay, that's, 904 divided by 3. 3 goes into 9 3 times. And then you get 0. But the next digit is also a 0. So you have to drag down another digit. But you can't do that without adding a 0 to the quotient. So you do that, and then you drag down another digit. 3 goes into 4 once with a remainder of 1. 301, remainder 1 is the answer to question number 3. Now we move on. Question number 4 has 833 divided by 4. Now, 4 goes into 8 2 times. And you drag down the next digit. But the next digit is a 3, and 4 doesn't go into 3. So you add a 0 to drag down the next digit. 33. 4 goes into 33 8 times with the remainder of 1. 33 minus 32, which is 4 times 8, is equal to 1. Our answer over here is 208, remainder 1. 541 divided by 5. 541 divided by 5. 5 goes into 5 once. You subtract, you get 0, and then you drag down the next digit, which is a 4. But then, well, you see, it's a 4. And that is a problem because 5 doesn't go into 4. So you add another 0 in the quotient. Well, you add your first 0 in the quotient, actually. And then you drag down the next digit. And you get 41. 5 goes into 41 8 times with a remainder of 1. Our answer is 108, remainder 1. Last question of the section, 817 divided by 2. 2 goes into 8 4 times, and then you subtract, and then you drag down the next digit, but the next digit doesn't work. Well, it does technically, yeah, it technically doesn't work. So you added 0 to the quotient, and you drag down the next digit. That's 2 goes into 17 8 times with a remainder of 1. 17 minus 16, which is 2 times 8, is equal to 1. 408, remainder 1 is our answer. Now we're going to proceed to the next section. Alright, so dividing greater numbers is, again, just like last chapter with multiplication, it's very similar. It's just that there's more place values. Now, divide 1,605 by 5. So 5 doesn't go into 1, but 5 goes into 16. So we're going to write the first number above the 6 in the 16. That's a 3 because 3 times 5 is equal to 15. And 16 minus 15 is 1. You want to take the largest multiple of the dividend that is smaller than what you're trying to divide into. You want to take the largest multiple that is smaller or equal to. Because you don't want negative numbers. And you don't want, well, the bit that you subtract out to be the factor you're dividing by or bigger. Because that just makes for very bad, you're going to have to regroup really weirdly for that. For this, you don't actually have to regroup. You drag down the next digit, you get 10, 5 goes into 10 twice, and then you get 0, but then you drag down the next digit, and that's a 5. 5 goes into 5 once. 5 minus 5, 0. The solution to this is 321. Now we move on to some practice problems. 2,694 divided by 2. So 2 goes into 2 once. And then you drag down the next digit. 2 goes into 6 3 times. And then you drag down the next digit. 2 goes into 9 4 times. And you have 1 remaining. You drag down the next digit, and it's 14. 2 goes into 14 7 times. The answer is 1,347. Question number 2 is 3,813 divided by 7. Now, 7 doesn't go into 3, but 7 does go into 38. 5 times. It does have a remainder, though. 3, and then you drag down the next number. 31. 7 goes into 31 4 times with a remainder. And that's 3. You drag down the next number, and it's 33. 7 goes into 33 4 times again, with a remainder of 5. Our solution is 544 remainder 5. We continue, and we come across 8,692 divided by 9. So 9 doesn't go into 8, but 9 does go into 86. It goes 9 times into 86. And 86 minus 9 times 9, or 81, is 5. You drag down the next digit, 59. 9 goes into 59 6 times. And you get 54. Because 9 times 6 is 54. 59 minus 54 is 5. And then you drag down the next number. That would result in 5. And 5 times 9 is 45. 52 minus 45 is equal to 7. And we can't really do anything more unless we want to end up with a decimal. Our solution is 965 remainder 7. We're moving on. 5,759 divided by 6. 6 doesn't go into 5, but it does go into 57. 9 times. So you write the 9 on top of the 7. 57 minus 54, which is 6 times 9, is 3. And then you drag down the next digit. As you can see, remembering your multiplication table is extremely important. Now 6 goes into 35 5 times. 35 minus 6 times 5, which is 30. 35 minus 30 is 5. And then you drag down the next digit. You end up with another 9. And that gives a remainder of 5. 959 remainder 5. What about... Okay. 4,498. This is not going to divide evenly, which means that it's not going to divide and end up with a whole number without a remainder. How do I know this? Because there's a trick to dividing by 8. If the last 3 digits together, which in this case is 498, is divisible by 8, then the entire number is divisible by 8. But if the last 4 digits aren't divisible by 8, like what we're seeing right here, then the number is not going to be divisible by 8. If you want to know whether or not a number is divisible by 4, then you would look at the last 2 digits. In this case, it's also a no. So 8 does not go into 4, but it does go into 44. 5 times 44 minus 40 is 4, and then you drag down the next digit, and then you do 6 times, which is 48. 49 minus 48 is 1, and then you drag down the next digit to get 18, and then it's 2. 2 times 8 is 16. 18 minus 16 is 2, the remainder is 2. 562 remainder 2 is our answer. Unless you want to go into decimals. Then the answer would be 562.25. Our next question is 7,395 divided by 3. Is it divisible by 3 though? It is. It's actually going to end up as a whole number. How do I know this? Because there's also a trick to dividing by 3. What is that trick? Well, if the sum of all the digits, in this case, 7 plus 3 plus 9 plus 5, if the sum of all those digits is divisible by 3, then the number will be divisible by 3. In this case, 7 plus 3 plus 9 plus 5 is equal to 24. 24 is equal to 3 times 8. And if you want to know 24, 2 plus 4 is 6. 6 is divisible by 3. Oh! Oh, okay. Anyhow, 3 goes into 7 twice. You end up with 1. You drag down the next digit, 13. 3 ends up with 13 4 times. That's 12. You get 1. You drag down the next digit. 3 goes in. 19 6 times. And you get 18. And then you subtract. And then you get the next digit. 1 5 15. 3 goes into 15 5 times. And it divides out evenly. Now, this isn't divisible by 9. Because if it's divisible by 9, well, 2 plus 4 plus 6 plus 5 isn't divisible by 3 anymore. And 9 is 3 plus 3. So if something is divisible by 9, it is also divisible by 3, and then that quotient will also be divisible by 3, because there's 2 3's in the factorization. You're learning prime factorization in grade 5, if I'm not mistaken. But, well, that's it for this chapter, and I guess I'll see you next chapter.